Ops. All right, here we go. We have a lot to do. Those of you who are going on retreat, please listen carefully. Life continues in that land, but everything will be available on video. And when you return from retreat, you will simply have to spend some time watching the videos and completing your notes. Okay? Anything that is assigned must be turned in by a week from Friday. Any missed quizzes or anything like that has to be done by a week from Friday. So you have all of next week to get it done. I don't know. So are we clear on that? So full credit, you've been on retreat, full credit to end by Friday. Next week, October 4th or something, that first Friday in October. Okay?
Is that the Friday that the quarter ends?
Yep. But I always give you a week after, it just so happens that's when it is. It has nothing to do with the end of the quarter. You get a week to get your life together. Okay? And get stuff turned in. Looks like we're missing Ronan.
I'm here. I'm just saying Sam's sick. Yeah.
Sam is still sick? Sam was not here the other day.
Yeah, he's sick.
Jalen is not here. London is back there. Okay. Oh no, who's that? Jack. Okay, well, let's pick up where we were. We have a lot to do and we don't want to fall behind. So, we have our notes out. And the last time we were together, we were working on some parametric things. And we decided, I can't remember the ordered pairs we had. -3. What was the actual SY ordered pair?
-2 and 3, -1 0, 0 -1, 1 0, 2 3, 13 8.
13?
Or 3 8.
3
4 15.
Okay, perfect. Thank you for writing those down for me. So now it says, C says, sketch by hand. Now, we had, I think, come up with an algebraic relationship by solving for T and plugging that in. Do you remember doing that?
Yeah.
Right? Now, that is going to be a parabola. Would you agree with me?
Yeah.
Let's go ahead and if we have to graph this parabola by hand, let's go ahead and clean it up a little bit. Looks like it's going to be x squared minus 1 if I just FOIL. What does that look like? You know what that looks like. Yeah. Down 1, opening up. So it looks like this. Would everybody agree with that? So bottom line, groupies, is you started with this, yucky yucky, but you eliminated the parameter and ended up with this handy dandy little equation. Now, look at your points. -2, it's really hard on my picture, but if I had done this like accurately, -2 3, -1 0, 0 -1, 1 0. Kids, does it look like these points are going to be graphing this thing? Absolutely. Absolutely. All right, now sketch the original equations on the calculator. right, this is brand new, you've never done this before. So I need you to get your calculator out and do what I say. Could we all graph x squared minus 1 on our calculator? Yeah, you could do that. We're gonna graph it parametrically. Now turn it off and turn it back on, and it'll show it's charged. Okay? So here we go. First thing I need to do is go to where it says mode. Look where my finger is, my index finger. See the button called mode? You want to press it, and you want to go down one of your options. For me, it's the 4th line down, but I'm not sure where it is on yours. But you see a PAR? As parametric. And we want to be in parametric mode. Okay? We were in function mode. Now we're in parametric mode. Okay? Now, go to y equals, and things look different now. What does it say? Remember, what did it used to say when I pressed y equals? Y equals. Now it says x equals and y equals. So now we're going to type in, for x equals, we're going to type t plus 1. And we're going to get the t the same place we get our x on our variable button. Now when you press that button, it says t, because we're in parametric mode, and it changed the variables. Plus 1. Oops. All right, now I go down to y equals, and I do t squared plus 2t. Now, I don't know how your window is set, just hit graph. Mine is all wonky, so I'm gonna hit zoom 6 to square my screen. Huh, did you get a parabola?
It's kind of long.
Okay, let's go back to our window now. Go back to window. And now we have to look at t, x, and y. Okay? So let's let our t's, what were our t's in our given? -3 to 3. So t min is -3. T max is +3. T step, we're going to talk about that in a second. But for now, make it 0.1. 0.1 for t step. I'm leaving my x's and y mins and maxes at -10 to 10. I'm going to hit graph and see what happens. Am I closer at least? All right, let's go ahead and change that window again. Let's make x min, let's make it -50. That doesn't help. Makes it worse. Let's try our t's. For t min, let's go with -10 and +10. And then I'll go back to -10. Did that do it for me?
Yeah.
So I just had to graph more points to get my calculator to do it. Okay? Now, you watched the graph, right? After we made that change, you saw a graph? All right, I want you to do something for me. Go back to your window and change T step to 1, regular 1, and hit graph. Did anything, as you watched it graph, the shape's the same, but as you watched it graph, did anything strike you as different? It went a whole lot faster. All right, let's go back and set it at T-step. Let's set it at 2. Now, was it even faster yet? But it seems a little bit less accurate than it did before. Would you agree?
Yeah.
All right, let's set it at 5. now it's lost its shape. It went really fast, but it lost its shape. Here's what we mean by T-step, you guys. You have these T values, and the problem told you, these are not X values, these were our T values, right? They said use these for your T's. How far apart are these? T-step was 1 in the given problem. Now, when I had you graph it originally, I had you do it with a 0.1, so your calculator didn't graph just -3 and -2. It graphed -2.9, -2.8, -2.7, and so on. It graphed every 0.1. Does that explain why it was a little slower? But it also gave you the best graph because it plotted a whole bunch of points. The bigger this gap is, the fewer points you plot, which is good for a speed standpoint, but it's not good for an accurate graph standpoint. You see what I'm saying? When I set that step at 5, then it's only plotting every 5 points. So then when it connects them, it doesn't have a nice shape. Does that make sense to you? So moral of the story, T-step needs to be small enough to get a good picture, but not so small it takes it a week to graph. All right, 0.1 is a great option. 0.1. All right, we got to repeat all those parts for the next problem, so let's go through those again, make sure everybody's up to par. First part says, find the points determined by these equations. So x equals 2t, y equals 3t minus 1. Here are my t values. -3, -2, 0, -1, 0, 1, 2, and 3. And I have to find my points. And here are my equations. So if I put in -3, I'm going to get -6, -10. Keep an eye on me, please. -4, -7, -2. Oh, wait. -4 would be. -1, -1, -4. 0, okay? All right, now I need to find a direct algebraic relationship. What I need to do?
50 myself.
I gotta somehow come up with something with no t's in it. So Dana says I could take my top equation and do this with it. And then take that guy and plug it in here. So y equals 3/2 x minus 1 if I put in x over 2 here. What shape is that? The last time we had parabola. What's that? A line. And the slope of a line is supposed to be 3/2. That means your y's should be going up by 3, are they? And your x's should be going up by 2. And then if we want to sketch that line, that's easy. It has a y-intercept at -1 and a slope of up 3 over 2. Up 3 over 2. It'd be better on graph paper. I don't have that. So there would be my y. let's put it in our calculator. So let's go to y equals. Take out the old equations, put in the new ones. So 2t, 2t and 3t minus 1. Now let's go to window and change that t step back to 0.1. And see if we get it. That looks kind of like that one. Good? Now, next time you go to graph something on your calculator, remember you're in parametric mode. So if you're going to graph a regular equation on your calculator, you're going to have to go back to mode and change it back into function. Everybody good with that? All right, we have one more thing to do, and then we're ready to start today's lesson. Okay, so we need to sketch and inverse. Okay, switching gears. Last time we talked about inverses. And what did we say happened with inverses? The x's and y's flip. So here's my original, and I'm going to go ahead and just plot or label these points. You don't have to do this. I'm doing it because it helps me figure out what's going on. Those are my original points for the original picture that I've drawn. Now, I'm going to graph the inverse. So I'm going to take each ordered pair and flip it. So I'll plot 0, -2. And 1, -1. And 0, 0. So there's the first part of the inverse graph. All right, then I'll plot -1, 1, -1, 2, and 0, 3. So easy. So easy to graph an inverse. Just flip-flop the ordered pairs. Now, gang, does that picture make sense? Well, it's not a function, but it makes total sense because the original picture was a triangle and a trapezoid on the x-axis. What do I have now? A triangle and a trapezoid on the y-axis. I switched my variables. The shape will never change. The inverse shape will be the same. It will just be oriented differently. We good? All right, you do the second one. Graph the inverse for B, or B. Does your picture look like mine over here? This guy right here, is that what your inverse looks like? I know you guys can't wait to get out of here, but will somebody talk to me, please? this should be your inverse right
Get
here.
it pretty quick. Yeah, it takes me a while. I gotta find the points.
Gotta find the point, okay, all right.
Mine does indeed look like that.
Well, that makes my life complete. I match Jake S. There we go. All right, everybody good on graphing and inverse? Okay, just to do a quick recap. If we have ordered pairs, if somebody gives me a set of ordered pairs and says find the inverse, I just flip flop them, right? That's how I do it graphically. If someone gives me an equation and says find the inverse, then I have to switch my x and y and solve for y. Remember that process? We did that the other day. Okay. All right. So what are we doing today? Well, I'm going to give you some graph paper if you want some. So if you want a couple pieces of graph paper, just grab a couple and pass them on. You're not obligated to use this at all, you guys, but if you want to, if it helps you, I'm fine with it. It's up to you.
How many do you
Just a couple. We'll be plenty, I think. I always have more. So. All right, now,
Can you pass them out?
pass them around. Yeah, pass them around. Take a couple, pass them around. All right, this picture right here is a picture of the original. This is the original. The thing I drew there, and I plotted some points specifically, that is my original picture. All of these things, A through E, are going to be variations of that picture. Okay, this is called we're transforming. These are our transformations. Transformations are simple if you know the rules. Okay? So, first problem says sketch 2 f of x. A number, a multiplier, a coefficient out in front is going to multiply the height of the picture, or in other words, it's going to multiply your y's. That should make sense to you because f of x is y. So this is basically saying 2 times y. Now, let's look at this point right here. The first point in the picture. What is the y value of that point? -3. If you times it by 2, the y value of that point is going to be negative 6? Wait, -3 times 2? -6? Okay, don't mess with me. So we're going down to -6. So at -2, I'm all the way down at -6. So the x isn't changing. This is the point -2, -3. It's becoming the point -2, -6. Now what about this one? This is the point -1, 0. What's going to happen to it?
0.
Nothing, because when you times 0 by anything, it doesn't change. This one is 0, 1. So when I times my y by 2, I get 0, 2. How about that guy right there? He's not changing. Because what's his y value? 0, and 0 times 2 is 0. That guy's not changing. How about this one? If I graph it right, his y is -2. So that one's going down to -4. What about that one? Staying the same. And this one, if I graphed it right, is that 2? Is that up 2? So it's gonna be up here. Now remember, the x's aren't changing. So I'm plotting a point where x is -2, -1, 0, 1, 2, 3, and 4. Now let's connect those dots. Do we have the same general shape?
Yeah.
But what has happened to it, it has been stretched. What do you think would happen if I put a 1/2 out here? That would
Get that into it.
shrink it, right?
Compress it.
Compress it. Yeah, these are all dilations. Yeah. All right, is everybody good with that? So our first transformation that we absolutely have to get nailed down is if we put a coefficient out in front, that is always gonna multiply the height. It's gonna multiply the y. So in this case, everything is 2 times bigger in the y direction. Okay? B, I think you already know, or at least you should already know. What is gonna happen in B, do you think?
It's gonna move to left 1.
These, when you put a number in there, that's gonna move you either left or right. And a +1 is gonna go left. So, what do you need to remember? I think you already know it, but you need to remember if you're adding or subtracting inside the parentheses, you're gonna go left or right. Adding takes you left, subtracting takes you okay? All right, so you're gonna go back to the original picture, always the original. And every point is going to be backed up 1 unit. So this isn't gonna be -2, -3, it's gonna be -3, -3. And this one isn't gonna be -1, 0, it's gonna be
2, 0.
-2, 0.
-1, 1.
You got it.
One right, I said 0, 0.
So here we go, you should be seeing your shape, you guys. Again, transformations aren't gonna change when we're doing these kind of transformations, aren't gonna change your basic shape. In this case, we're just moving it. So what am I ready for? This is 2, that's gonna be 1, -2. 2, 0. And that one's gonna be 3, 2. Is there anybody that's got a question about that? Does that make sense to you? Are you able to do that? Raise your hand up, we got this. Okay, everybody keeping up okay? All right, now we're going, I'm gonna leave my original picture here. Now I'm going to the next one, which is a negative out in front. What does a negative out in front do? Upside down. So you gotta be careful when you say flip it. If you wanna say flip it, that's fine, but it's flipped across the x-axis.
So the y would inverse or the y, I think the y is, yeah. So the y, if it was a positive.
Yes, so your y's, it says negative y. So your y's are gonna change sign. So, first point is -2, -3. So it's gonna become -2, +3.
3, Joe.
Oh, I forgot to show.
Joe's allowed to make a mistake.
Yes.
He's close to perfect. All right, how about -1, 0?
0. So it was like 0.
It's just staying the same because, remember, we're changing the sign on y. And if y is 0, it's 0. All right, 0, 1 is gonna become
Negative 1.
0, negative 1. Again, that one's not changing.
Hold on 1 second. Wait, what's up first?
So 2, 2.
This one is 2, negative 2,
Alright, let's
so
keep
he'll
positive.
become 2, 2. And this one is 3, 0, he's staying the same. And this one is 4, 2, so he becomes 4, negative 2.
I got it right.
So why wouldn't it be like multiply by negative 1?
It is. And so you're multiplying the y by negative 1. So it leaves all the heights the same, but they're upside down. Yep, you can think about it either way, that's fine.
That would be the absolute value.
All right, you okay with so far? Now we're gonna throw a couple wacky ones in. All right, here we go. What do you think's happening there?
Make the y positive.
Make all the y's positive. Make all the y's positive. Now, I think of this one as bottom two.
Plus.
And here's why I think of it that way. If I'm making the y's positive, then this is gonna go up, isn't it? These are already positive, so they're not changing. This is gonna go up, and that's gonna stay the same. So anything on the bottom of the picture is gonna go up. That's the only change that's gonna be made. Your y's are gonna be positive. So instead of being negative 2, negative 3, it's gonna be negative 2,
3.
positive 3. This one isn't gonna change. So now I have this. That part's not gonna change. So I'm still gonna have that point and this point. So this came up, this stayed the same. Now this guy is gonna be 2, 2. And that's gonna stay up there. Absolute value will change your shape. It will look different. When you take the absolute value, it's exactly what Dana said, your y's become positive. Which means if my arm is the x-axis, anything down here is gonna get flipped up. If it's up here already, it's gonna stay there. Bottom comes up. We got it? That might be a new one for you. Okay. Now E. First of all, do you see the difference between D and E?
Yes. Yep. Make all the
You
x
gotta pay
positive.
attention because they are different transformations.
Huge.
Significant difference, yeah. All right, now, here's what I want you to do, okay? I want you to draw the right side of the picture exactly as it is. So, 0, 1, 1, 0, 2, negative 2, 3, 0, and 4, 2. So there,
What'd you do?
I drew the right side of my picture.
Just like, alright.
Just draw it exactly as it is. And here's why. What happens when you take the absolute value of something positive?
stays positive.
Yeah, it doesn't change. So the right side of the picture isn't gonna change. All right, now here's where it gets really crazy. Reproduce that on the other side. So here,
Just like a mirror.
it's a mirror. Very good, I love that word. I love that word, it's a mirror. So what we do for this transformation is you draw the right side exactly as it
That's a
is,
W.
and then you mirror it onto the left. The original left side of the picture is gone. This is gone. We draw the right and mirror it on the left. And here's why. If you put in a negative x, it's exactly the same as putting in a positive x. So whatever happened with the positive x's is what's gonna happen with the negative x's. This transformation loses the left side of the picture. The left side is gone, and it's replaced by the mirror of the right. That's tricky.
Sure.
All right. Let's pile on a little bit here. We have a new starting picture. So my starting picture, you might want to go ahead and label those points. You don't have to, but you might want to do that.
You guys
I'm not sure why there's all this jibber jabbing going on. I know it's the end of the day and you're all super sad that we don't have class tomorrow.
Wait, we don't?
I know.
Why not
Total
just-
bummer. But never fear, I'll see you Wednesday, Thursday, and Friday.
You will see me. You will not see me. Nice. You will
All
not
right,
see me.
here's our original. Everybody okay? All right, first transformation. Actually, two things are happening.
Yeah, that sure is.
So we have that negative and then a +2. You should know that means we're going up 2, right? That's what that means. But this negative is different than the other negative,
Yeah.
because the other negative was just out in front of the whole thing. That negative, the original negative out in front, flipped us upside down. That negative is gonna flip us sideways. So this is gonna be a sideways flip. Now, I'm gonna say that, but what it really is a reflection across the y-axis. So it's taking the right side of the picture and moving it to the left, and vice versa, okay?
And not just like that one.
Wait, this is our picture?
Oh.
And no, it's not, because the right came onto the left, but then what was on the left would have to be the right too. Yeah, so no, this is not that at all. Even if it were the right picture, I mean, the right starting picture, it's not, they're different. Okay, now, me personally, because I'm 65 and have a hard time keeping track of stuff, I do this in 2 steps, okay? You don't have to. If you can manage it all in one, that's fine. But I'm gonna do it in 2. So the first thing I'm gonna do is go across my y-axis. So what that means is, that point isn't gonna change. So 0, -2 isn't gonna change. But this point that was right one is now gonna be left one. That's this point. That point, which was right two, is now gonna be left two. And left three. So, is everybody okay so far?
Yeah.
Alright, now I gotta do this side too, yep, yep, you're changing the sign on all of your X's. That's all you're doing. You're changing the sign on all your X's. So this one was negative, it becomes positive. This becomes 2-1.
You know, what is your?
And 3-0. You're not done yet. But let's pause there for a second. Are you okay with that being a flip-flop across the y-axis? As Tyler said, you're just changing the sign on all of your x's.
Why wasn't it -3, +2? Because you're going up 2.
Well, wait a minute, I haven't done that part yet.
Oh.
All I've done is this part. Now, like I said, if you can do it all at once, that's awesome. I can't, so I'm doing it one step at a time. So I've got the negative part covered. Would you agree with that? Now, I'm gonna take the whole shebang and move it up 2. Everything goes up 2. So that's 2, this is 3. So now what's happening is whatever my y values were, like this was 0.123, this was -3.1, it's now going to become -3.3. I like to draw that in, that's like my new axis. You don't have to draw that in at all, unless it's necessary, but certainly you can. Everybody, all along with it? All right, let's look at the next one. Oh my goodness.
Final next question. 2.
Okay. Now, the y values aren't going to change. The y values are not going to change. Did you agree?
Yep.
Okay. So what's going to happen to my picture?
It'll shrink.
Actually,
It's going to shrink.
just the opposite's going to happen.
Oh.
Okay, just the opposite's going to happen. Because a coefficient, I want you to think about this for a minute. When we have this, and we have this, when we're dealing inside the parentheses, it's the opposite, right?
Oh.
Right? This is just up 2, just like you would imagine, but this is actually left 2.
Yeah.
So when we put a 2, or let's say we put a 1/2 out in front of the function, that does exactly what you think. That multiplies your y's by 1/2. Yep, makes it shrinker, more small, right? What do you think happens when you put that 1/2 on the x?
Multiply by 2.
It actually divides by 1/2, which is timesing by 2. Okay? So it's going to make your picture twice as wide. It's a wide thing. So, back to the original. So I have this point down here at 0. That point isn't going to change. okay? But this triangle, that in original form, went right one and left one, is now gonna go right two and left two. Now, it's still the same depth, that hasn't changed. But everything is twice as wide as it was to start with. All your X's are doubled. Your X's are doubled. So this X, which was at 2, will now be at
4.
So 4, 1. And then 6, 1. And then that guy was at negative 2, 1. So now he's at negative 4, 1. And negative 6, 0. So this guy right here divides your X's by 1/2, which is the same as multiplying the X's by 2. I don't care which way you think about it. But it's not half as wide, it's twice as wide.
So it's ever like, you can only do multiplication,
Oh, well, this kind of is divided by, it's X divided by 2, but that will usually be written as something times X. But if it were X divided by 3, that's 1/3 X, right?
Can it ever be like negative 1/2 X?
Oh, yeah.
Oh.
So remember, what does a negative inside do?
Or go.
Flips this way. So that would be two things. You'd be flipping this way and making it either shorter or longer, depending on what your number was. Okay? All right, C. Here's my original pictures. Now, C has a lot going on. So again, my choice is to do it in 2 steps. Your choice is whatever you want your choice to be, I don't care. But let's talk about what happens. Taking the absolute value makes all the y's positive. So I call this bottoms up. All the y's become positive. And then we're going to go up 1. So I'm going to do this part first. I'm doing it in 2 parts. I don't care. Let's just end up at the same place. So bottoms up. All right, all of this part's going to stay the same because it's already up. This guy's going up. And that's already staying. Is that okay with everybody for the first part? Now, I'm going to pick the whole shebang up 1 minute. So this is coming up here, here, here. How was that? Did you keep up with all that? I know there's a lot to remember. Blue is my final answer. All right, let's get the last one done. And then you don't have to listen to me. right, so what's happening in this?
So all the right sides, flip it
So
upside down.
this is right side,
Flip upside down. Flip upside down.
mirror left,
Yeah.
and then this is upside down. So is everybody okay?
Yep.
Yeah.
So I'm coming back to my original, and I'm going to draw
Right
the
side.
right side.
Upside down.
Well, I'm not gonna do that because it's too much for my feeble brain, but you can. You can do that. So there is the right side.
Wait, what does it say? Upside?
Yeah.
Upside down. All right, now I'm gonna mirror that over here on the left. So that is a picture of this. Notice what happened to this over here. Gone. The left side disappears. It's replaced by the right side. Now what do I do?
Flip it upside down.
Turn the whole shebang upside down. So that means I'm changing, Tyler, the signs on.
Wow.
So this is gonna become negative, negative, that's zero. So that's gonna go up to positive. This is gonna go. So the blue, I'll erase my black. The blue is the answer to the question.
So like,
Is that okay? All right, while you're, I think I have enough. Maybe I don't have any, oh, here we go. I'm gonna hand out, who's going on retreat? All right, I'm gonna give you an extra practice sheet, which we may do in class, but I don't have enough for everybody. So I'm gonna get the retreat kids theirs. And then I'll make more copies and have one for everybody. Everybody got one that's one on the sheet? Okay, I'll have these available. Okay? We're not having a quiz next time, we're gonna practice some more.
Mrs. Ford, what's the Roman numeral XXIV?
XXID would be 24.
Okay, thanks.